future engineers. Welcome to my YouTube channel. If you're still new to my channel, please don't forget to subscribe, press the notification bell, and share my videos if you find them helpful so that I will also be inspired to do more videos which are important in your studies as civil engineering students. So the two problems are taken from the book by Munson and Yang about fluid mechanics, and this is about determining pressure at one vessel given the layers of fluids in the tube connecting them. And the second one is the application of pressure on curved or plane surfaces. So here we go. This is the first problem. For the inclined tube manometer shown, the pressure in pipe A is 4.14 kilopascals, and the fluid in both pipes A and B is water, and the gauge fluid in the manometer has a specific gravity of 2.6. So what is the pressure in pipe B corresponding to the differential reading shown? So this is the figure. In computing for the pressure in pipe B, we have to sum up pressure from one point to another. So passing through this tube. And remember that going down is we have to increase the pressure by the formula specific weight of that fluid times the vertical distance move. And going up is minus gamma times also height. So beginning with point A, so we sum up pressure, we mark these points, and remember that at points where at points on the same horizontal plane in a homogeneous fluid at rest, the pressure is the same. So this is 1, this is mark 1 prime, the pressure is the same. Then from 1 prime we proceed to 2, then 2 to B. So sum up pressure from A to B. So 4.14 pressure at A. So we go down. This is water plus 9.81 times 0.075. Then we jump here. Then we rise by 200 sine 30 or 0.2 meter sine of 30. And this gauge liquid has specific gravity of 2.6. So it's specific weight. So minus because we rise minus 2.6 times 9.81. That's the specific weight of this gauge liquid. Then the vertical distance move is 0.2 meter sine of 30. Then from 0.2 to B, that's also rising. So minus, this is water. So 9.81 times 0.075. Then equals pressure at B. Solving for the pressure at B, the pressure at B is 1.589 kilopascals. So I hope you are able to follow the solution. That's a simple problem. Okay, let's proceed to the second problem on the application of pressure on curved and plane surfaces. So we use the concept of pressure on curved surfaces here to answer this problem. Concrete is poured into the form as shown to produce a set of steps. Determine the weight of the sandbag needed to keep the bottomless forms from lifting off the ground. The weight of the forms is 85 pounds and the specific weight of concrete is 150 pounds per cubic foot. So this is the project, and we have to form these stairs. We have to pour concrete here and we have a form. So of course, without this sandbag that will hold this upper form in place, then this will rise up because of the pressure due to concrete. So this is the view in this position, in this side, and this is the sandbag. And to draw the free body diagram, we have the weight of the sandbag unknown. This is, by the way, from the ends of the contact curve or point, we draw horizontal lines up to the imaginary concrete surface. So which is this? So this is the end. And this is the volume to be considered in computing that upward force which causes this uh, form to collapse if there is no sandbag positioned in this portion here or in this portion here. So we have the weight of the sandbag that is unknown. Then we have an upward force equal to specific weight of concrete times volume inside this imaginary space. So we call that FV. Then we have the weight of this form, which is equal to 85 pounds. So summation forces Y equals 0. FV equals weight of sandbag plus 85. So that's the working equation. F sub V, upward force equals downward force, weight of sandbag plus 85. Now to solve for this FV here, it is equal to specific weight of concrete, which is 150 pounds per cubic foot, times the volume. And the volume is the area of this rectangle times 3 feet, then plus the area of this rectangle times another 3 feet. That's the volume. So the area, we must convert the area to square foot because the dimensions here are in inches. So this is 10 by 8 plus 8 is 16 over 12. So 10 over 12 times, so 150 pounds per cubic foot times 10 over 12 times 16 over 12 plus this area here is 10 over 12 times 8 over 12. Then the length perpendicular to the screen is 3 feet as given here. So this is consistent. This must be in pounds. So computing that, that is equal to 750 pounds. So finally, substitute in that equation, 750 equals weight of sandbag plus 85. So the weight of the sandbag is 665 pounds. So that's it for these two problems. I hope that you are able to follow the solutions